what is the meaning of the statement of this? So the meaning of the statement is that a square is divisible by 5. A square is divisible by 5, students, and therefore we can say that a is also divisible by 5, because now here students that as a square is divisible by 5, then of course that a is divisible by 5. It's not possible at any cost. It cannot be happen. At any cost, it cannot be happen, student, and that means which is not possible, and therefore this is our contradiction. This is a contradiction. Okay, this is a contradiction. And this is on the left hand side there is a root 5. Now we know that root 5 is an irrational number, and on the right hand side there are the a and b, that are the integers, and it is of the form a upon 7b. So a upon 7b automatically called it as the rational number. So here students, the left hand side is irrational, right hand side is rational. So that means students, it is not possible. Hello students, welcome in our channel Class 10 ncert SSC Math with Sujatag. Welcome students in the exercise 1.2 of the chapter 1 real number. So let us start the question 1 to solve. So now here the first question is students, prove that root 5 is irrational number. So now here students, we have to prove that root 5 is irrational number. That means here students, we have to prove that root 5 is not rational number. So now here students, we can assume that such a way that root 5 is a rational number, students. So what will happen here? So I here assume that here first, assume that root 5 is rational number, rational number. I assume that root 5 is rational number. If that assumption is wrong, then our final answer will be root 5 is an irrational number. Okay student, so let us see what will happen here. So assume that root 5 is rational number. As the root 5 is rational number, students, so the rational number, form of the rational number, and that is equal to a upon b. So I write that root 5 is equal to a upon b form. So what is a and b, students? Here a and b are co-prime. A and b are co-prime, students. Okay, a and b are co-prime, and where b is not equal to 0. So now here students, the next step is that cross multiplication. So root 5 multiply b is equal to a. So now here students, I squaring on both the sides, squaring on both the sides, squaring on both the sides. Okay, so I get that root 5 multiply b whole bracket square is equal to a whole bracket square. Square of root 5, that means 5. Square of b, that means b square. So which is equal to a square. 5b square is equal to a square. So now here students, what is the statement of this? What is the statement of this? Or what is the meaning of the statement of this? So the meaning of the statement is that a square is divisible by 5. A square is divisible by 5, students. And therefore we can say that a is also divisible by 5, because now here students that as a square is divisible by 5, then of course that a is divisible by 5. Okay, so I call these two statements as first statement. Okay, and then now the second part, I take the other integer c, other than a and b. So I write taking c as any integer such that a is equal to 5c. Okay, let a is equal to 5c. So now here students, the next part is that squaring on both the sides, squaring on both the sides. So now here a square is equal to 5c whole bracket square. So here a square is equal to 25c square. But now here students, here that from this statement students, here I call it as the first one, this one. And from this equation that a square is equal to 5b square. So I write here 5b square is equal to 25c square. So that means here students, b square is equal to 25c square upon 5. So that means here students, 5 ones are 5, 5 5s are 25. So b square is equal to 5c square. So now here students, what is the meaning of this statement? The meaning of this statement is that b square is divisible by 5. And it means that b is also divisible by 5. Now here students, we call it as the second one statement. So now observe carefully the first one statement and the second one statement. That here first statement is saying that A is divisible by 5. Here in this second statement say that B is divisible by 5. That means here students, A and B divisible by common factor 5. So here from 1 and 2, here we say from 1 and 2, A and B divisible by, or A and B having common factor, A and B having common factor 5. Okay students, but now it is a contradiction. It is not possible. So here students, this is contradiction. And that contradiction arises. This is contradiction arises because of our wrong assumption. And what is our wrong assumption? Our wrong assumption was that root 5 is rational number. So it is wrong. So our correct statement is that root 5 is irrational. So finally we say that therefore root 5 is irrational. This is the easiest method students, and very easy example. Okay students, now let us see the next one example students. The next one example is that prove that 3 plus root 5 is irrational. Same to same, copy to copy example students. Okay, so the steps are same as before example, earlier example that we saw here. Okay, so now here first our assumption. So here we say that assume that 3 plus 2 root 5 is rational. As students, we say it is a rational. So what is the form of the rational? A upon B. So we can write 3 plus 2 root 5 is equal to A upon B form. And here A and B are co-prime. Where B is not equal to 0. So now here students, we further simplify this equation. 2 root 5 is equal to A upon B minus 3. So now here 2 root 5 is equal to A minus 3B upon B. So that means here further simplify that we get that A minus 3B upon 2B. So now here students, that A and B are integers. A and B are co-prime. And here also that root 5 is a rational number. We earlier saw that root 5 is rational number. Root 5 is irrational number students. And here that means left hand side is irrational number and A and B are integers, and that's why this side, right hand side, is a rational number students. And that means here students, root 5 is irrational and A minus 3B upon 2B is rational number. Now here students, this will be contradiction, that irrational number is equal to irrational number. No, there is wrong assumption students. It is not possible, and it is not possible because of our wrong assumption. And so that's why we say that 3 plus 2 root 5 is rational number. It is not possible that irrational number is equal to rational number. Okay students, so here we say that rational, here first say that irrational number is equal to rational number, which is not possible. This is contradiction. This is a contradiction, and that arises because of our wrong assumption. Okay, so we correct our assumption, that is root 3 plus 2 root 5 is irrational. 2 root 5 is irrational. Okay students, 3 plus 2 root 5 is irrational. So such a way you can solve such a type of the example. So now students, let us see the next one example. Next one example is that prove that the following are irrationals. So first one is that 1 upon root 2. So we say that assume that 1 upon root 2 is rational. Okay, as 1 upon root 2 is rational, that means students 1 upon root 2 can be written as a upon b form, where a and b are co-prime. A and b are co-prime, and where b is not equal to 0, where b is not equal to 0. Okay students, now here students, that cross multiplying, that here b is equal to a root 2, that means b upon a is equal to root 2. So now here at this step, that b upon a, here students, b upon a is rational number. B upon a is rational number, and root 2 is irrational number. Root 2 is irrational number. So now here students, that rational number is equal to irrational number, which is not possible, okay, and that means here students, this is a contradiction, and that arisen due to our wrong assumption, okay, this is a wrong assumption, and okay, due to our wrong assumption, this is a contradiction, and that means here students, we say 1 upon root 2 is irrational. 1 upon root 2 is irrational. Okay students, the next one example students, then let us see the next one example students, 7 root 5. Now here students, we have to prove that 7 root 5 is an irrational number, and that means why? That means we have to prove that 7 root 5 is not a rational number. So here first, there is our assumption part, and we assume that students, here we assume that 7 root 5 is a rational number. It's a rational number. Okay, now here 7 root 5, we assume that 7 root 5 is a rational number. That means students, what is the form of the rational number? The form of the rational number is a upon b, and so that's why we write 7 root 5 is equal to a upon b. And what are the a and b? A and b are the co-primes. A and b are integers that are co-prime. Okay students, that are co-prime, and where b is not equal to 0. Okay students, now here students, that we further simplify this equation, that is root 5 is equal to a upon 7b. Now here observe this step students, that is on the left hand side there is a root 5. Now we know that root 5 is an irrational number, and on the right hand side there are the a and b, that are the integers, and it is of the form a upon 7b. So a upon 7b automatically called it as the rational number. So here students, the left hand side is irrational, the right hand side is rational. So that means students, it is not possible. It cannot be possible. So that means students, it is a contradiction. Okay students, so first we write down that root 5 is an irrational number. Root 5 is an irrational number, and a upon 7b is a rational number. And here students, in this condition we get irrational number is equal to rational number. But here, which is not possible, we get irrational number is equal to rational number, and which is not possible. So now here, which is not possible, so this is a contradiction. And here students, this contradiction arises due to our wrong assumption. So here I say that, therefore, this contradiction arises due to our wrong assumption. And what is the wrong assumption, students? What is the assumption our, and which is we call that wrong assumption? That is 7 root 5 is a rational number, and that means, students, if it is a wrong assumption, then our correct statement will be, students, our correct statement will be 7 root 5 is an irrational number. It's an irrational number. So now such a way we can prove that 7 root 5 is an irrational number. Very easy example, students, and very simplest method that you can easily understand, student. So follow these steps, students, and practice this method. Example, student, 6 plus root 2. So now here we have to prove that 6 plus root 2 as irrational number. So that means our assumption part. First I say that assume 6 plus root 2 is a rational. It's a rational number. As we know that rational number is in the form of a upon b. So I write that 6 plus root 2 is equal to a upon b. Okay. So where the condition apply, a and b are co-prime. A and B are co-prime, and where B is not equal to 0. So now here I further simplify that root 2 is equal to A upon B minus 6. That means root 2 is equal to A minus 6B upon B. So now here, students, we know that A and B are the integers. A and B are the integers, and B is not equal to 0. That means here, students, A minus 6B upon B is rational number, and here, students, that the left hand side part, that root 2 is irrational number. So first I write down that root 2 is irrational number, and A minus 6B upon B is a rational number. So now here that we get, students, we get that irrational number is equal to rational number. Okay, we get irrational number is equal to irrational number. But which is not possible, students. Which is not possible. At any cost, it cannot be happen. At any cost, it cannot be happen, students. And that means which is not possible. And therefore, this is our contradiction. This is a contradiction. Okay, this is a contradiction. And this contradiction arises. This contradiction arises due to our wrong assumption, students. Our wrong assumption. Okay, we assume that here we assume that 6 plus root 2 is a rational number. So it is a wrong assumption, and as it is a wrong assumption, that means our correct statement is that 6 plus root 2 is irrational number. Therefore, 6 plus root 2 is irrational number. Okay, student. So here when we completed here exercise 1.2 of the chapter first, real number. If you like our content, students, then subscribe our channel and share these videos to your friends.